In the third exercise, we are asked to fix the function sumFixMe in the caller save file. So the specific instruction is to only modify the code at the different to-do points right here. So we can remove the to's here and write some code here. We don't modify main, and we definitely don't modify this function to make it work. Now, we want a correct execution to end with no errors. If I run this immediately, execution terminated with errors. There's something going wrong here. We want the value 3 and A0, and we want the value deadbeef and S0. Now, this might be a strange exercise, and let's look at the sum function. It seems to just work, or it should be a good implementation of sum. Why? It just sums the value in A0 and A1, the first two parameters, and it returns that into A0. So it seems like it should be a fine sum function. Now we're going to see why doesn't this work. And how or what is the goal here is again thinking about caller save and callee save registers. Okay, let's go look at this. Our very first function that we've provided, it can be, so my seems Rars has crashed really. No. Okay, I'm back. Great. So our very first function, caller save register wipe. It's a very, very nice function that simply does one thing. It wipes all of the registers that it's allowed to freely wipe. So remember, when you call a function, all of the caller save registers can be overwritten freely by the function that you just called. The function has no obligation at all to save the values of a caller save register. They don't have to. They have the responsibility to save the values of the callee save registers, not of the caller save. So that's why we wrote a function that simply does exactly what it's allowed to do. Wipe all of the caller save registers. RA, T1 to T6, A0 to A7. All of these registers, whenever you call a function, afterwards you cannot be guaranteed that this function didn't modify these variables. So this one will explicitly wipe all of them. Okay, so if we don't fix anything, well, this line, it will cause us to lose the value of our parameters. So A0 and A1 contains the parameters of sum, A and B, if you want to do A plus B. But we wipe them by calling caller save register wipe. We wipe them, and then afterwards, right here, well, now we are adding them together again. But this is now 0 because we called caller save register wipe. Our job before we call a caller save register, before we call a function, is to save all caller save registers. And after this function, you need to restore them again. So that's what these to-dos want you to do. Save caller save registers, restore caller save registers. And then this caller save register wipe function doesn't do anything. Next point is going to be the second part of this exercise, where let's say we do this. We restore both, so we back up A0 and A1, we restore A0 and A1, now we sum them together into S0. Now S0 is a callee save register. What does that mean? Sum is obligated to save the value of the callee save registers. So let us, for example, quickly fix our caller save registers here, right? We need to save 3 different registers. I'm going to quickly copy this from the solution, and paste it here. We save 3 registers. We reserve 3 words on a stack. We save return value A1 and A0, because those 3 we will need afterwards. RA is very important. RA, again, is a caller save register. It will be overwritten here, and also by the JAL. So you need to save it. Then, after the function is done, we can restore the call or save registers. Let's do that. Like this. And you could conclude, I'm done. And you are almost done with the half of the exercise. Let me compile and run this. And if we go and look at the requirements, we will see it should terminate without errors. It happened without errors. The value 3 in A0. So let us look at the value of A0. That's 3. The third requirement is the value deadbeef in S0. But in S0, there is not a value deadbeef right now. Why not? Let's look at our main function here, which we cannot modify. Our main function loaded the value deadbeef into S0. And apparently, after executing some fixme, deadbeef is not an S0 anymore. That's not allowed. That's a breaking of convention. S0 is a callee save register. That means if a function modifies S0, they have to restore the old value before they return from the function. So, when we modify here the value, when we modify S0 by storing the sum of A0 and A1 in there, we lose the deadbeef value. We have to restore it again at the end of the function. So that's what this last to do is. You have to restore the old value of S0, but before you can restore it, you have to back it up on the stack first. So let's look at the full solution now. We have, at the second part of the exercise, before we overwrite this value in a callee save register, first we save it to the stack, and then once we're done with S0, we can restore the deadbeef value from the stack again. And then, only then, once we've also restored our stack pointer, same thing, also a callee save register, so you have to restore it. And only now, all of the callee save registers are stored, and only then we can return from the function. And if we will compile this, assemble this, and run, and we will see now, in S0, we have this value. If you put it as a hexadecimal value, it's the value deadbeef. So, the challenge here in this exercise is to really, and after this exercise, you should really try to understand the difference between a caller save register and a callee save register. That's all this exercise is about, caller save versus callee save. Both can be backed up on the stack, but the difference is who has to back them up. Who is obligated to back them up? And now think also a little bit further about the purpose of this. If you call a function and you want to make sure that the function doesn't override a certain value, well, put your value in a callee save register like S0. Then you don't need to store it on the stack. You know the function is not allowed to overwrite it, so use S0 for values that need to stay, that have a long lifetime, that need to stay there in between function calls. On the other hand, if you just have a temporary value, then use the T registers, the temporary registers. Or the A registers, which are also temporary registers. They can be overwritten by any function. So if you don't need the value, then you can just use the T values. Now for function arguments, we always are obligated to use the A registers. So in that case, you don't have much choice, and you will have to back them up each time you call a new function.